All right, let's get right into it. We're going to talk about a technology that honestly feels a bit like alchemy, a way to take some of the most stubborn, indestructible poisons we've ever made and just unmake them. It's a wild story of chemistry, incredible engineering, and maybe, just maybe, a reset button for the planet.
And I'm not being philosophical here. I'm talking about your actual physical body. Right now, inside of you are man-made chemicals that your body has no idea how to break down, that nature can't break down. They are, for all intents and purposes, a permanent part of you, and pretty much every other living thing on Earth.
The name they came up with, Forever Chemicals, pretty much nails it. These things, PFAS for short, were designed to last. They're the magic behind your non-stick pans, your waterproof hiking boots, your stain-proof couch. And that magic comes from their carbon-fluorine bond, which is basically the superglue of the molecular world. But the very thing that makes them so useful is also our biggest nightmare. They just don't go away.
So you're probably thinking, okay, so what? Why can't we just treat them like other toxic waste? Burn them up or bury them deep underground. Well, that's where the story takes a turn. Our usual playbook? It's completely useless here. This is such a perfect way to describe it. You know the myth of Sisyphus, pushing that giant boulder up a hill forever? That's us with PFAS. We use our current methods to push this contamination up the hill, but it just rolls right back down. And sometimes it comes back even scarier than before. Let me show you what I mean.
So option 1, just burn it. The problem is, to even have a prayer of breaking that carbon-fluorine bond, you need incredibly high temperatures. We're talking over 1,000 degrees Celsius. But here's the kicker. If that furnace temperature drops, even for a moment, you don't destroy the PFAS. You just shatter them into smaller toxic gases that go right up the smokestack and into the atmosphere, only to rain down somewhere else. You haven't solved a thing. You've just made the problem airborne.
Okay, so what about filtering it out of our water? We use these giant activated carbon filters. And look, they work. They pull the PFAS out of the water. Great. But they don't destroy anything. All you've done is move the PFAS from the water to a filter. So now you have a filter that's loaded with toxic waste. And what do you do with that? Well, you have to bury it or try to burn it. And we're right back where we started. The boulder just rolled back down the hill.
So if our trusted tools are failing us, it's starting to sound pretty hopeless, right? Well, what if the answer wasn't some new exotic chemical, but something incredibly common, just used in a way that's totally radical? What if the answer was water?
We all learned about solid, liquid, and gas in school. But it turns out there's another state of matter, a fourth state. If you put water under enough heat and enough pressure, it becomes something else entirely. It's not a liquid, and it's not a gas. It becomes a supercritical fluid, a strange in-between state with some truly incredible superpowers.
So how do you get there? You need two things, extreme heat and extreme pressure. First, you have to heat the water to over 700 degrees Fahrenheit. And at the exact same time, you squeeze it with over 3,000 pounds per square inch of pressure. To put that in perspective, that's like the pressure a mile deep in the ocean. It's immense.
Now, this is where the real magic happens. Under those conditions, water's entire personality flips. You know how oil and water don't mix? That's because normal water is polar, while supercritical water becomes nonpolar. All of a sudden, it loves to dissolve things like oil and other organic stuff, including PFAS, but it suddenly hates salt and kicks it out. It's a complete 180.
And that is the secret weapon. Because the PFAS are now totally dissolved in this supercritical water, you can mix in oxygen, and it gets right up close and personal with every single molecule. This triggers a kind of instant, flameless fire, a contained oxidation reaction that is so violent it just rips that unbreakable carbon-fluorine bond to shreds, for good.
And the result of this process? A destruction rate of 99.9999%. Let me just pause on that. 6 nines. That's not a typo. That means for every 1 million molecules of forever chemicals that go into the reactor, maybe one comes out. It is as close to total annihilation as you can possibly get.
Okay, so if this technology, it's called Supercritical Water Oxidation, or SCWO, is basically a magic bullet, the big question is, why isn't it everywhere? Well, because harnessing this kind of power is an absolute engineering nightmare. Seriously, it's like trying to keep a jet engine running smoothly inside an active volcano.
For years, engineers fought two huge monsters. First, corrosion. The process is so aggressive it can eat through solid stainless steel in a matter of days. And second, remember how the water kicks out all the salts?
Well, those salts turn into hard solids and clog the whole system up, kind of like cholesterol causing a heart attack in the machine. It's only thanks to some seriously advanced space-age materials and brilliant new reactor designs that we're finally winning that fight.
So as you can imagine, those space-age materials are not cheap. And for a long time, the price tag made this technology seem like just an expensive science experiment. But now, the math is starting to look very, very different.
Look, nobody's saying this technology is cheap to build. It's a big investment up front. But now, compare that cost to the cost of doing nothing. We're talking about tens of billions of dollars in lawsuits, massive cleanup bills, and new government fines that are coming down the pipeline. All of a sudden, that big investment starts to look less like an expense and more like an insurance policy against total financial catastrophe.
And this isn't just a theory. It's happening now. The people with the most urgent problems are jumping on this. The U.S. military is using mobile SCWO units, literally built inside shipping containers, to clean up military bases that are soaked in toxic firefighting foam. And chemical companies are using it to destroy their nastiest waste right at the factory, so they don't have to risk shipping it across the country. So you see, this isn't just about a better way to get rid of waste. The implications of this are huge, touching everything from our health to social justice. And think about this for a second. Historically, where does toxic waste go? It gets trucked away from one community and dumped or burned in another, usually a poorer one. SCWO offers a terminal solution. The pollution is destroyed right where it's made. There's no toxic ash to bury, no contaminated smoke. It ends the whole process of just kicking our toxic problems down the road for someone else to deal with.
So let's just put them head to head one last time. Incineration runs hotter, is way less effective, and creates a whole new set of pollution problems. Supercritical water oxidation runs cooler, is staggeringly more efficient, and it's a closed loop. The only things that come out are harmless: carbon dioxide, plain water, and simple, clean salts. It's a clean kill. There's no other way to put it.
Ultimately, this is what it all comes down to. For so long, that word forever has sounded like a prison sentence, a permanent mistake we couldn't undo. But what this technology proves is that forever is no longer a fact. It's a choice. We made these chemicals, and for a long time we were helpless against them. But now we have the tool to unmake them. The only question left is, will we choose to use it?